question 303. This is on LeetCode. I'll definitely add the link to the description so you guys can also go and practice. And I really would encourage you to do so. Granted, we're going to solve it together so you guys can see how I would solve this problem. But I would really encourage you to stop the video, especially when you feel like you really understand. Stop it and then work it out to see how far you can get. So let's read it and let's see what it is that they're actually asking for. So given an integer array nums, handle multiple queries of the following type. Calculate the sum of the element of nums between indices left and right inclusive, where left is greater than or equal to right. Then I would come here as well because they want us to return the sum of the element of nums between indices left and right inclusive. Look, basically what they want us to do, right? If you come here to the explanation that they give you, is we're going to be given an array. And what they want from you is from the left index to the right index, they want you to figure out the sum left and right inclusive. Literally, that just means, for example, this is the 0th index, 1, 2, 3, and this is the 3rd index. It just means from here to here, give us what is the sum? So it would be -2 plus 0 plus 3 plus -5. It could be anything from here. So this is the 0, 1, 2, 3, 4. Yeah, let's say to the 4th index. So it'd be the same thing. It would be 3 minus 5, 2. Because we go back to the question. Right, what did they ask us for? They asked us to return the sum of elements between indices left and right. So an example could be something like from here, so the 0th index, that's L, till here, which is the 3rd index. And so remember when they said inclusive, this just means it will be the -2, so at the 0th index, and the -5 are included in the sum. So it would be -2 plus 0 plus 3 plus -5. That's all they're saying with the word inclusive. I know sometimes when you sort of read the questions, they're not always very instinctive, but I think the more questions you practice, the easier it becomes to understand because it's a pattern, right? You recognize the pattern. Initially, your first thing is, oh, well, this is not that difficult. I could just loop, right? I could loop from the Lth index to the right index and just get the sum of that. Same if it were to be moved, right? It could be that they are saying to you, well, left could be here, and then right could be here, right? Or we could have kept it the same. It doesn't matter. So in your head, you go, well, I mean, I could just literally loop through here and there. So it would be 2, well, the 2nd index plus 3rd index value plus 4th index value. The problem with this solution is that it is an ON time complexity. And I think I did say to you guys, if you haven't done time complexity, I really would recommend you do that because we're going to be referring to this a lot because it does really help us to see if our algorithm is efficient, right? So that means every single time this algorithm of ours is run, we're using an O of n time complexity. Whereas with the prefix-sum, our complexity, I should actually just write all of this down. So the brute force solution, right, it's an O of n time complexity. However, if we use the prefix-sum, it actually becomes an O of 1 time complexity, and that's exactly what we want because it's the more efficient solution. Okay, so what exactly is this pattern? Basically what we're going to do, right? Because if you look at this, if we break it down and try to make it easier, right? So instead of looking at the ranges, let's put that aside from now, right? Because we want to make this easy for ourselves so that we can see the pattern here. If we had to figure out from the 0th position to the 5th position, what is the sum of each following index? What do I mean by that? So we're going to create another array. Right, I'm just going to put this here. Now that we've removed the left and right indices, instead of doing the range, trying to figure out the range, so for example, from here to here, what is the sum? We're going to start right from the beginning, right? Because I think it's a lot easier if you just start at the 0th index all the way to the last one, right? So we want to figure out, well, what is the sum for each successive index? So we create another array. Prefix-sum really is the sum of the original array, right? We just create a new array so that we can keep track of what that sum is for each index. So at P0, what is the sum? Just another reminder, I know this feels silly, but I also recognize that English is not everyone's first language. When we talk about a sum in mathematics, it's just plus, right? So what is the sum of A? It literally means just this plus that, plus that, plus that. Okay, coming back to the main point. So what is the sum at P0? Well, I mean, at P0, the sum really is just -2. Why? Because there is no value before that, right? There's nothing here. And then at P1, what is the sum? Well, then we would go -2 plus 0. It would still just give us -2. And then at the second index, what is the sum? We'd go, well, -2 plus 0 is still -2 plus 3 gives us 1. And then we go to the third index. Same thing again. It's -2 plus 0, we know gives us -2, plus 3, we know gives us 1, plus -5, well, that's just going to give us -4. But I'm hoping that at this point, you guys have sort of figured out that there's a pattern here that is emerging. Because for all of them, but I'm just going to focus on P3, we didn't need to go back from the 0th index to figure out this answer. We literally could have just taken this, the previous sum, right? So at P2, added it to A3 to get this answer, right? 1 plus -5 gives us 4. And so this is sort of the pattern that we see here, right? So at P0, it's just A0 because again, there's nothing that we can add it with. At P1, it's A0 plus A1. And so when you look at this, you sort of see this pattern that emerges, which is the current P, so let's just say Pn, is equal to the previous P index plus the current P index, right? So it's here. This is basically the pattern that emerges, this right here. And remember when I said to you, the problem with brute forcing it is that every single time we'd literally have to loop here, 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 right? Or we'd go here, here, here. So basically every single time it would be of the time complexity ON. And we don't want that, right? We want to make it as efficient as we can. Actually, let me rephrase that. ON is technically very efficient, but we can make it even more efficient using the prefix sum. See in our pattern, right? So for the next one, which is P4, right? P4, we know that we don't have to start from the 0th index. We could literally just go, well, then the previous sum plus the current value, which is -4 plus 2. What does that give us? Well, that's going to give us -2. Same thing for the last one. We don't have to start from 0. We now know that we can take the previous sum and add it to the current value. So -2 plus -1 is going to give us -3. So, well, how does this help us to solve our LeetCode problem, right? So let's go back to the LeetCode problem to see what it is that they were asking us. So going back to our LeetCode problem, right? So they're asking for a range, whereas in our examples, we started at 0 all the way to the last index to come up with this new prefix-sum subarray, right? Which is the sum of each successive index. Whereas the LeetCode, what they are asking for is the sum between two indexes left and right, right? As you can see here, and I mean, I could just move that to here. It doesn't really matter what indexes they give us. Using this new subarray of ours, we'll be able to give them the answer in O of 1 time complexity, which is very efficient, and that's what we're looking for. And so basically what we're going to do is we're going to figure out first, the first step we want to do is to create this new array, right? So we're going to loop through these this original array to come up with our new subarray, which is the prefix sum of each of the indices, and using left and right, right? So we're going to take right, the value at right, so p right, and we're going to minus the value at p left, right? So now we're back at LeetCode, and remember, what is it that we're going to try and do first? Well, the first thing we want to try and do is to come up with this new array that I've been referring to, right? Our prefix-sum array. So first thing we do is we're going to initialize an array. Let's just call it prefix. This is where we're going to save, right? This is where we're going to save the values that we get from adding the values at the different indexes, right? And then we're going to initialize a variable called current, right? You can call it current total. So then we're going to loop, because remember, we have to create this new array. And as I've been stressing, the whole point is that we just create this array once, whereas in the previous brute force solution, every single time you wanted to work out the range sum, you would have had to keep looping, right? We're not going to do that. This is just once and then we're done. So we'll go look for number in nums. What we want to do is we want to add num in this current. So for example, at the 0th index, it was -2 plus 0 is going to give us -2. And then we're going to append, right, this sum that we get to our new array that we're creating, right? So this here, this logic here is creating our new array. First thing that we want is to create this array, right? So every time we loop, we go, okay, well, for number in nums, so this is nums, right? They gave us nums. So we go, okay, well, at the first indice, the answer is 2. The second indice, we know that it's that plus that. Third indice, we know it's that plus that. It's all three of them. And then at the third indice, we know it's that plus that plus that plus that, right? So this is what we're doing once. We're not going to do this again. Really important for you to remember this. We're only doing this once. Then down here, we're going to find out the range. So when it comes to the right sum, it's actually really simple, right? We go right sum is equal to, let's get our new array to that index, right? Whereas with the left sum, there it's, again, it's not complicated, it's not rocket science. We just have an extra step where we go, okay, let's take our subarray. Then we go at the left index -1 because we want it to be inclusive. We go if left, right? So if our left index is greater than 0, so this is just a ternary. If this is true, do that. Else, it's just 0, right? So this is just to make sure that our algorithm, it doesn't break anything. Then we go right sum minus left sum, right? So let's just test it to see what happens, right? So it's passed. Now let's submit so that it can get tested with different test cases, and it is passed and it is accepted. You can actually analyze the complexity here if you want. And I mean, I would also really recommend you guys make notes, right, while you're doing it yourself, because it's a lot easier for you to come back to your own notes and to understand and to remember why you solved something the way that you did, compared to sort of referring back to this video, because this is how you get stuck in tutorial hell. You really do have to just go in and do it. I would recommend do it. Once you've done it, erase everything and do it again, right? Until you get comfortable. Like do it 2 or 3 times and then go to the next easy prefix-sum solution. And I promise you, the more you do it, the more you start to recognize this pattern. Okay, hopefully this has been really helpful. I'll probably come with another video with the next pattern, right? Cheers. Good luck.